Density of an object is the mass over volume and represented by rho. The pressure is the force of the object divided by the area it is being applied on. We can also find the pressure of a fluid using the equation rho gh is equal to pressure. These three lead us to Pascal's principle, which states that if an external pressure is exerted upon a fluid that's confined, the pressure increases throughout the fluid evenly. This gives us P1 equals P2 and allows us to exert a 20 Newton force on a 20 centimeter squared surface and get a 400 Newton force out of a 400 centimeter squared surface. However, work is still conserved as the amount of distance given by each force is changed depending on how much force is exerted. This leads us to Archimedes' principle, which states that the buoyancy force of an object is just the mass of the fluid displaced times gravity, or the density of the fluid times the volume of the object times gravity. This is shown by the mass times gravity of the object minus the buoyancy force gives us the force of tension of the object in the water. Now we can go to Bernoulli's theorem, which states that at a higher pressure there is a less velocity, and at a lower pressure there's a higher velocity. Derivations of Bernoulli's theorems can be found in Torricelli's theorem, which states that V equals the square root of 2gh when a water is coming out of a very large barrel out of a small spigot.
This is brought to you by Made in China.